Okay, so in this video we're looking at bearings, and let's get into it. So bearings are widely used in navigation. So things like ships, aircraft, and walkers, hikers often use bearings. And for example, you might be asked this following question. So we might ask, what is the bearing of Leeds from Liverpool? And we'll get into it in a second how you actually do this. But just briefly, it means, right, you've got to be using a protractor for this topic. So you're going to need a protractor, which is this thing over here. And there's a few really important things that you need to recognize when you use bearings, which are the following. Okay, so here we go. Yeah, you got three key things when you use bearings, and these are really important, so I'd recommend you make a note of these. And the first one is that bearings are always written in three figures. So essentially what we're doing here is you're measuring, because you're going from Liverpool, you're measuring the angle from Liverpool. Okay, you can be using your protractor to measure this angle, which is here. Okay, so this angle here. And a bearing is written in three figures. So let's just say you measured the angle to be 47 degrees. It probably isn't, but let's just say you did. You would write it as 047 because it's got to have three numbers in that bearing, and that's really important. If your number was 7, it would be 007. If it was like 302, you just keep it as 302 because there's already three figures in that. That's the first key thing about bearings. The second key thing is that bearings are always measured from the north direction. So you can see here, because I'm going from Liverpool is here, this up here is the northerly direction, and you've got to have a north arrow pointing from the place that you're going from. That's really important. So bearings are always measured from the north direction. And the third really important thing is this: bearings are always measured clockwise. So that because we're going from Liverpool to Leeds, you are measuring this angle. This here is clockwise. So clockwise, just so we know, right, this is, sorry, literally the way that a clock goes. Okay, so if you've got a clock, okay, with your numbers on it, so that would be 12, 1, 2, 3, so on and so forth. Okay, the way that the clock, the arm ticks, it goes this way. That is what I mean by clockwise. Okay, that's really important. So we're going this way, which is this way. Okay, that's really important. So definitely I would make a note of that on your notepad if you need to, and make sure we learn those. That's really important. But now we're going to actually go into the application of measuring bearings. Okay, so I've got two questions here, and then we're going to be looking at a real life application on this one. But this is really good to differentiate a few really key points. The first one is saying, what is the bearing of Leeds from Liverpool, as opposed to the second one, which is the same map, very similar, but what is the bearing of Liverpool from Leeds? So there's a slight difference there, from Liverpool and from Leeds. Now, of course, for this, let's get out our protractor. There we go. Okay, first of all, we're going from Liverpool, so that's why the arrow is at Liverpool, going up in this direction. And then we're going to go and be measuring this angle here, because remember, you're measuring in the clockwise direction, so you're measuring this angle here. Now let's go and get our protractor, and let's go and put it on, making sure that the centre of the protractor, so what I mean by that is this part here, the centre of your protractor, goes on the centre, or the point where the angle meets, which is here. So let's go and put this down here. And then you can measure this in a few different ways, but you want for me, I'm going to go from here, because, right, the centres line up, which is good, and the line here is lined up with the blue line, and this is the point 0. Okay, so I'm starting at 0. You've always got to start your angle at 0. Okay, so 0, 10, 20, 30. You could also, if you wanted to, you could measure this differently, just to show you. You could put your protractor like this. Okay, there we go. And you could start again from here, and start from the inside this time, and start at 0 and go 10, 20, 30, 40, so on and so forth. You both get the same answer, okay? But you've got to start at 0. You don't start at, that is 180. It's not on this protractor for some reason, but you always have got to start at 0. That's crucial. Anyway, I'm going to get my protractor to go how it was initially, because that's just the way that I would do it on this example. There we go. So we're lined up, and you can't see it, but right, we're starting lined up, we're at 0. So 0, 10, 20, 30, 40, 50, 60, 65, 66, 67. So the bearing here is 67 degrees, okay, which is the same thing, just to show you. Okay, I'm going to write my answers down first of all, before I forget. That is 67, but remember, a bearing is in three figures, so 0, 6, 7 degrees, and that is your answer. There you go. And it makes sense, right? Because if we think about our angles, this is an acute angle. It is small, so that's less than 90. It makes sense. But just to show you, just to make it really, really clear, I won't do this again. I won't waste any time doing this again. But I think it's important that we do get this. If I started from this way, and I started this time at 0, you've got to start at 0, not 180. So 0, 10, 20, 30, 40, 50, 60. You get the same answer. You get 67, which is really important. Okay, good. Let's look at the second one now, which is now saying, what is the bearing of Liverpool from Leeds? So just your Leeds and Liverpool, they switched around. We're now going from Leeds. And because we're now going from Leeds means that your northerly arrow is going from Leeds. And again, a bearing you measure clockwise. And we know that clockwise is where you're going in the same way that the clock goes, which is this way. So you're actually measuring this large angle here. Now, the issue I've got a little bit, it's not really an issue, but this protractor only goes from 0 to 180. And this angle is going to be bigger than 180. But what I can do and what I can know is that we know around a full circle, okay, there's 360 degrees. So around from here, around the whole thing, it's going to be 360. So if I get this angle here, this smaller one, and take it away from 360, that will leave me with this angle here, which is what I want. So let's go and do that. That's going to be the best way to approach this question. Let's spin this around. There we go. Let's go and put it lined up. So let's go measure it like this. There we go. So again, you can do this in two different ways. But I'm going to go from here. I'm starting at 0, which is good. And I've got to start at 0, not 180. So 0, 10, 20, 30, 40, 50, all the way around until I get to my line. And the line should keep going really, but you can see it's between 110 and 120, exactly 115, which is good. So this angle here, let's do it in blue this time, is equal to 115 degrees. But we want this angle here, and we know that this angle is going to be 360. Take away the one I just measured, 115, which is going to be equal to 360. Take away 115 is equal to 245 degrees. So the answer here is 245 degrees. And it's already in 3 figures, so I just leave it like this. I don't need to go and add in any zeros, but that is my answer. Okay, so it's just being careful with the subtle variations, right? From is where your north arrow goes, and you measure clockwise, and it's got to be in 3 figures. Okay, actually, I think I'm going to stop it for that video, and in the next video, we're going to look at the real-life application of using bearings. Okay, thank you.